Hello everyone, my name is Susan Woodard. Today I'll be presenting on AppArmor and HTTPS hardening. This session will cover three main areas. First, an introduction to AppArmor and its protection capabilities for Linux systems. Second, an overview of HTTPS protocol and its comparison to HTTP. And third, a step-by-step setup and hardening process for HTTPS on Windows IIS and Linux Apache servers. Finally, I'll show how we verify our configurations in the lab. Let's start with AppArmor. AppArmor is the Linux security module that enforces mandatory access control. Instead of relying solely on traditional Unix permissions, AppArmor utilizes security profiles to restrict an application's actions. For instance, an Apache process can be allowed to read web files, but not access system files. Profiles can operate in two modes: complain mode, where violations are logged but not blocked, and enforce mode, where violations are actively prevented. This allows administrators to test and refine security profiles before fully enforcing them. To confirm AppArmor is running, we use the command sudo aa status. This command informs us of the number of profiles loaded, which ones are in force or complain mode, and the number of processes confined. For example, the output might say 117 profiles are loaded, 112 are in enforce mode, and 5 are in complain mode. This is especially important in our labs because the grading system will check that AppArmor is active and protecting key services. AppArmor hardening recommendations. There are three best practices for hardening Linux with AppArmor. 1. Keep critical services in force mode. This ensures services like SSH or Apache are always restricted. 2. Maintain and update profiles regularly. As software changes, so must its security profiles. Also, disable unnecessary services to reduce the attack surface. And 3. Use complain mode during testing. When rolling out new services, run in complain mode to generate logs, then switch to enforce one stable. This cycle ensures we maintain strong least privilege protections. HTTP versus HTTPS. Now let's shift to networking protocols. HTTP operates on port 80 and sends all traffic in plain text. This means usernames, passwords, and other sensitive information can be intercepted. HTTPS, on the other hand, runs on port 443 and uses TLS to encrypt communication. It ensures three things: confidentiality so outsiders can't read the data, integrity to prevent data from being altered in transit, and authenticity to confirm that the server is who it claims to be. That's why HTTPS has become the standard for secure web communication. HTTPS key concepts. When configuring HTTPS, there are some key requirements. First, older versions of SSL and TLS are insecure. SSL v2, SSL v3, TLS 1.0, and TLS 1.1 have all been deprecated due to vulnerabilities. Instead, we must enforce TLS 1.2 or newer, with TLS 1.3 as the recommended default because it provides stronger security and faster handshakes. Second, we should enable HSTS, which stands for HTTP Strict Transport Security. This forces clients only to use HTTPS connections, preventing attackers from tricking users into connecting over HTTP. Let's look at Windows IIS. The setup is straightforward. We first install IIS, then add a certificate. For the lab, we can generate a self-signed certificate through In Production. A certificate authority would be required. Once the certificate is ready, we bind the site to HTTPS on port 443. In IIS Manager, that's done under Site, Bindings, Add HTTPS. To verify the configuration, we can run test net connection, computer name localhost, port 443 in PowerShell, or scan the server for another machine with netmap. Seeing port 443 open confirms HTTPS is enabled. IIS hardening recommendations. To harden IIS, we take 3 important steps. Disable old protocols and weak ciphers. You can see those listed in the red square labeled number 1. This ensure only TLS 1.2 and 1.3 are enabled. Second, enable HSTS so browsers refuse to downgrade to HTTP. And third, use proper certificate hygiene, such as server name indication, short-lived certificates, and OCSP stapling to confirm certificates haven't been revoked. These steps make IIS significantly more secure in both lab and production settings. Apache HTTPS setup. Now on the Linux side, we'll configure Apache. First install Apache and open SSL, then enable the SSL module with A2 in mode SSL and activate the default SSL site. If needed, we generate a self-signed certificate with OpenSSL. In the site's configuration file, we enable SSL engine on and point to the certificate and key files. After reloading Apache and allowing the firewall rule for port 443, we confirm the service with SS toolpin grip 443 or with nmap. This shows our server is listening securely on port 443. Apache hardening recommendations. For Apache, we again apply at least 3 hardening steps. Restrict protocols so only TLS 1.2 and TLS 1.3 are allowed. This is set with SSL protocol directive. Number 2, enable HSTS by adding the header strict transport security. Number 3, enable OCSP stapling and security headings like X-frame options and X-content type options. These ensure encrypted, authenticated sessions that are resilient against modern web attacks. Some of these recommendations seem to be repetitive, but they are necessary that we restrict protocols and only use the TLS 1.2 and the TLS 1.3. Finally, let's talk about verification. In the lab, we'll use nmap. Although you see a reference to ZenMap on the slide, we are not allowed to use it because we are not allowed to install GUI on the Linux server. So the only option in this case is going to be nmap. The goal is simple. We should see port 443 open with HTTPS service detected. We may also see port 80 open, but if so, it should be redirected to HTTPS. The expected scan result is something like 443/TCP open HTTPS apostrophe along with details of the TLS version and certificate. This provides our confirmation is correct and that our servers are properly hardened. To conclude, these configurations and best practices are based on official documentation from Ubuntu, Apache, Microsoft, IETF, and Mozilla. Following these guidelines ensures we build a secure lab environment and also gain skills that translate directly to production environments.